The idea of this video is to introduce you to the type of regression line we're going to use in this class. We are going to use a regression line known as the least squares regression line. Now there's a bunch of different types of regression out there, and in this course again we're going to stick with the LSRL. Now the notes in this video correspond to the bottom of page 4. Okay, so the idea is that when a scatter plot shows a linear relationship, we want to be able to summarize the overall pattern. We do that by drawing a line on the scatter plot. Now, in general, a regression line is a line that describes how the response variable y changes with your explanatory variable x. So again, remember, y is your response variable and x is our explanatory variable. Now, the regression line allows us to make predictions. So once we have created the regression line, we can predict the value of y for a given value of x. Now just make note that regression, unlike correlation, is going to require you to have an explanatory response relationship. If we have a scatter plot, we need to designate what our y is and what our x is, because our line is going to be based on our explanatory variable and then describing how our response variable changes. So you need to make sure that you have a specific explanatory and a specific response variable. All right, so in this class, we are going to be using the least squares regression line. Now the form of this line is y equals a plus bx. So this is a general form of your least squares regression line. A is our y-intercept and b now is our slope. So the idea of a least squares regression line, and this graph isn't anywhere in your packet, I just wanted to describe to you what a least squares regression line is. So say I have 10 points here, and I drew in what I estimated to be the line of best fit. I'm looking at each point, and I'm looking at the distance from the line. So let's call this distance 1, okay, the distance from the point to the line. And then here my point is below, so I'm going to call this D2. And I'm going to keep doing that. I'm going to go through drawing the distance from each point to the line, and they're all going to be labeled as D something. Okay, the idea of the least squares regression line is I'm going to take all the differences and I'm going to call this as capital D, and we're going to look at the distance from the first point to the line, and I'm going to square it, plus the distance from the second point to the line, and I'm going to square it, and I would do that for all the points. Now the reason we square it is because if you notice down here I have a negative distance, and since we're talking about the distance from a point to a line, I would want all my distances to be positive. So I would go ahead and square all of them. Now this right here is known as the sum of the distances from the line. Now the goal in the least squares regression line is to minimize this distance. And so that's why it's called the least squares regression line, is because these are all squares, I'm squaring each distance, and I want to find the least sum of my squares. Now the best linear model will have the smallest sum of squares. So in our least squares regression line, again, we're minimizing the sum of the distances from the regression line. Now, back in your packet on page 4, you have this picture, and this picture kind of illustrates the same thing. We have our scatter plot, which we learned how to do in class today, and then we're going to add our least squares regression line, and our goal again is to minimize the sum of the squares.